Hello everybody, it's been a while since we've made a video. Hope you guys are doing well. Hopefully you got that quiz done. If you haven't, go do that real quick. If you have questions on it, let me know. But we are moving on, okay? Today we're moving on to Chapter 8. Chapter 8, Intro to Trig. So for those of you who go on to do trig and calculus, this stuff's the base information that you're going to need. Today, going to spend a little time reviewing because in order to move on, we got to make sure we know about things like the Pythagorean theorem. So 8.1's all about the Pythagorean theorem. So yes, I'm aware that a lot of the stuff we're going to go through, I hope you already know. And then at the end, there's a new rule that I don't think you know yet. But it's actually a pretty simple day, and we're going to keep this video pretty short, okay? So first things first, we have to remember the Pythagorean theorem, okay? Pythagorean theorem, side note, always has to do with a right triangle, okay? Remember, you can only use the Pythagorean theorem if you have a right triangle, meaning they have to give you that piece of information, okay? That piece of information. They have to tell us that this is, in fact, a right triangle. Then from there, a lot of you hopefully remember this. A, B, and C, obviously, when we work with them, they're numbers, but as always, when I get to teach you a theorem, or at least reteach it, I do it all on variables, so don't get confused by A, B, and C. Those are just numbers, okay? Pythagorean theorem, all it says is that if I square A and square B, then that all, and I add it together, that's going to equal C squared, okay? Just quick refresher, the number one mistake I see is people mix these up and they put the hypotenuse on the left side being added to something, okay? Remember, another way to think of it is the larger side is always going to be C. Whatever the larger side is, that's always your C value, okay? So, we get these if we put numbers in there. So if I come back in here and I say, like, this is 3, this is 4, and this is 5, I can test it, I can solve it and be like, okay, that means that 3 squared plus 4 squared has to equal 5 squared. And we do it, we get 9 plus 16 equals 25. 25 equals 25. Okay, so that's an example of how it works. That's what it looks like. That's Pythagorean theorem. Hopefully you get all a refresher for you. Obviously, let's just start with one quick example of the way we can use this or the way you might see this. I might give you a right triangle like this one, tell you it's a right triangle, and say something like, okay, X is there. Let's call this 9, and let's call this 25. Then you would go and you'd say, okay, A, B, and C. Again, being careful of the warning I told you. C is always the hypotenuse, so always across from the right angle. So that means 25 must be my C value, okay? Which leaves my left for A and B, so I have 9 squared plus X squared, okay? Now it's just algebra. Now I go through and I just solve for X. So here I'd go through and I'd say 81 plus X squared is gonna equal, don't know 25 times 25 off the top of my head. Get my calculator. $625. Now I continue solving. I'd go through and I'd say, okay, subtract 81. So X squared equals 544. And then the last thing would be to take the square root. If I have an X squared and I want to get X by itself, well, what's the opposite of squaring something? I'd have to take the square root. Okay, the square root. And the square root of 544 544 square rooted. Whoops. Give me a second. Sorry, you can probably hear my dogs in the background again. Okay. I think I made a mistake somewhere. Let me just double check my math. $544 square root. So what we end up with is 23.5 3, and I rounded that, as you're going to do. Right triangles, right? You're going to run into a lot of decimals. Okay? Not always going to be real clean looking. All right? So that's how we would use the Pythagorean theorem. Okay, I'm going to pause it real quick, put some other stuff up on the board, and we'll move on to some of the newer stuff. All right, so the next piece, which is some new material, right? I'm hoping Pythagorean theorem, setting it up, even solving for x. I think we've done that. I believe you did that in Miss Moss's class, in the earlier math class. So hopefully that was for you. Now on to some of the new stuff. You might have even learned this at some point, okay? First thing is Pythagorean triples, okay? It's just a shortcut for us. And what a Pythagorean triple is basically the very obvious sides of right triangles. So the base is 3, 4, and 5. Okay, 3 squared 9, 4 squared 16. We showed that one, right? That's what we showed here, was that 25 equals 25. Okay, that is the base of Pythagorean triples. Now, what the rest of the list is, and what the rule says is, anytime you take all 3 of these numbers and multiply them by the same amount, they're automatically going to be sides that work for a right triangle. So now we're not solving, we're just saying, like, are things a right triangle? In this case, if I take 3, 4, and 5, and if I look at 6, 8, and 10, I took the 3, 4, and 5, multiplied it by 2. I know automatically 6, 8, and 10 will be the sides of a right triangle. So if I made a triangle with sides 6, 8, and 10, it will be a right triangle. Okay, and I can do that with any multiple. This list goes on forever. The reason that's helpful is because the second part's going to be not just, hey, what's x in this Pythagorean, or in this triangle using Pythagorean theorem. Now it's, here's all 3 sides. Are these right triangles? So you'll notice the pictures I drew, I didn't put a right triangle box in there because I'm not telling you it's a right triangle. I'm saying, here's the sides of a triangle. Is it a right triangle? So the first thing to do would be, if you're really good and you get these down pretty quickly, would just to think, is this a Pythagorean triple? Okay. Now, the actual rule says, if I can plug the sides into the Pythagorean theorem, and it's true, then I know it is a right triangle. Okay, so, and I should label these, let's call this example 1, example 2, and example 3. Okay? In example 1, pretty easy, especially if I have this written down, 6, 8, and 10. 6, 8, and 10. Well, I can stop right there and go, yeah, that's a Pythagorean triple, therefore, that has to be a right triangle. Okay? If I do it the long way, what I'm saying is, okay, I want to test it, and I want to do 6 squared plus 8 squared equals 10 squared. If that ends up to be true, if they are equal, then I know it's a right triangle. Of course, like I said, we did the shortcut, so we already know it should work. Okay, 6 squared, 36, plus 64 equals 100. We add those together. 100 equals 100. It works. So my answer is yes. This is a right triangle. Okay, I've shown that it has to be a right triangle based on its side lengths. Okay. We go to the second example, 30, 40, and 55. Ooh, a little bit bigger numbers, not on our list, but I can think about it. I go, all right, 30 and 40 look pretty, look like something happening to our original Pythagorean triple, okay? Obviously, they're both being multiplied by 10. So the only way this could be a right triangle is if C is part of that Pythagorean triple. And if you think about it, you'd say, okay, if it's 3 times 10 and 4 times 10, the only number that'll work is 5 times 10, which is 50, and that's not what we have. So again, I'm using the shortcut of Pythagorean triple to know right away this is not a right triangle. Okay? Now, we can do it the long way. We can go through and say 30 squared plus 40 squared equals 55 squared. And we can test it. We can say, okay, I know that if this is true, those have to be equal. So what I get is 900 plus 1600 equals, I don't know 55 squared off the top of my head, 33,025. And what I get is, I would add those together. And I get 2,500 equals 3,025. Okay? And we look at that and we say, okay, is that a true statement? No. 2,500 is not equal to 3,025. Okay? So I would say those are not equal. Therefore, this is not a right triangle. Okay, again, two methods. You can use the shortcut method, which I'm very okay with. If you are able to look through that and use the reasoning and say, well, that wouldn't work as a Pythagorean triple, then you can say, if two of them match what would be a Pythagorean triple and the third one doesn't, then you can say it won't work. Or you can do it the long way. You can write it out, you can solve it and see if it's true. Okay, last one here, 3 is 18, 24, and 28. Again, I can go through 18. Oh, that's actually up here, 18, 24, and 30. So that means this would have to be 30, and it is not. So right away I know this probably is not a Pythagorean, or this is not a right triangle. Okay, because it doesn't fit. Two of them fit a Pythagorean triple, the third one did not. Again, long way of solving it. 18 squared plus 24 squared equals 28 squared. And I go through and solve that one. Okay, so I do 18 squared is 324. 24 squared is 576. And 28 squared is 784. When I add those together, I end up with the statement 900 equals 784. Which again, we look at and we say, well, that's not a true statement. Those two numbers aren't equal. Therefore, we know by the rule that this is not a right triangle. Okay, so I would say, nope, not a right triangle. So that's how we use the Pythagorean theorem to prove something's a right triangle. So far we have solving for a variable or a missing side. We now have using the Pythagorean theorem to show if something's a right triangle. And then finally, there's one last piece, and that piece is we can actually determine one last little detail about the triangle based on what we find. So first, the obvious one, if they're equal, if you plug it into the Pythagorean theorem and you get two equal numbers, then they are a right, or that figure is a right triangle. Okay? Here's the new part. If I get it and they're not equal, there's actually something I know. Okay, and here's how it's written out. It says if a squared plus b squared is less than c squared. Okay, so that means if I add these up and I find that the number on the left is smaller than the number on the right, then this is an obtuse triangle. If a squared plus b squared is greater than c squared, obviously it would be the opposite, which is an acute triangle. Okay? And then the third piece is the one we learned at the beginning. If a squared plus b squared equals c squared, then that is a right triangle. Okay? So for example, we can go through and add a piece of information here. We look here and say, okay, they equaled, right triangle. 2, we said they're not a right triangle, but I can say something more. I can look here and go, all right, 2,500 equals 3,025. Okay? So that looks like the left side is less than the right side. Okay, so this is what I'm dealing with. That means I know this is an obtuse triangle. Okay, it's an obtuse triangle. I look at the next example, example 3, and I say, okay, 900 equals 784. Well, that wasn't true. 900 bigger than 784. So the left side is bigger than the right side. It's greater. Then that means it fits this piece. So we know number 3 is an acute triangle. Okay? So we can use it and pick out one more piece of information. So those are our 3 uses of the Pythagorean theorem we're going over today. Again, just to review, one would be using the actual Pythagorean theorem to find a missing value. Okay? Find a side. They tell us, hey, this is a right triangle. Here's some information. Find the missing side. The second way we use Pythagorean theorem is this a right triangle? They give us 3 sides. We test it using the Pythagorean theorem and say, yes, this is a right triangle, or no, this is not. And then the third way we use it is using this inequality rule that says, I know it's not a right triangle, but I also know, based on which side was bigger, the a squared and b squared or the c squared, I can then determine is it obtuse or acute. Okay? That's what we're doing for today. I got no practice problems for you till Friday. I just want you to get this information down, try and think through it, and then we'll come back and practice it and see if we actually understand what's going on. As always, make sure you're asking questions. Let me know if you need anything. shoot me an email. Just say what's up, anything you need. Otherwise, have a great day. Make sure you're staying busy, doing something productive. I will see you all on Friday. Enjoy the rest of your week.